Hey everyone, I'm Jen Goldbeck, and I'm here to do a quick Gephi tutorial for you to analyze some networks. Gephi is an open source graph visualization tool. It's based on Java. It'll run on any platform. You can download it at gephi.org. I have no hand in making Gephi, but I've made a lot of YouTube tutorials about it. I teach it in my classes. And so yeah, you can download a copy of it at gephi.org. It's free. And it's a great way to analyze and understand networks. So we're going to jump in and look at some data, and I'm going to walk you through the process of analyzing networks that I would do. All right, so what I've done here is open the network with the IP addresses straight up in Gephi. This is exactly how it opens. So we've got this big square of nodes here. I haven't done any layout yet. What we can see up here is that we have a big and super dense network, which is often challenging to visualize. So we'll eventually do some filtering on that. The next thing I would do is go to the data laboratory and just see what we have in terms of data. For each node, we have an ID and a label, which seem to match, and then a node type. So that will be a useful thing to look at since there's just a few types. And under edges, we have a weight. And if we sort, we can see that the weight's always 1. And then connections here. So the interesting thing here is in the nodes that we have a node type. So we come back to the overview. The first thing I would do with a network like this is apply a giant component filter. That'll just get rid of any nodes that are singletons floating on the outside. So we drag that down here and click filter. And it didn't do much to reduce what we have. We can see we basically have the whole network there. But it's always a good first step if you've got a huge network to get rid of those little ones that would be floating around. Next, I'm going to use the Forced Atlas 2. There's a ton of good network layout algorithms in here, but Forced Atlas 2 is by far the fastest one, and I think it gives a really nice layout. For a network this big, you definitely want something fast. So we'll take that and run it. And we can see it thinking down here, and already we've got a pretty decent picture. I'm going to stop it right there since it's just kind of jiggling around. Because this network's so big, that could run for a really long time, and I can already hear my computer fans spinning up because it's computationally pretty hard. So now we've got this laid out. Let's click to center here, and we can see the whole network. And before I even color code anything, what I can see is a bunch of, let's see if we can get it here, these sort of starbursty things, where we have one node that's connected to a big clump here that isn't really connected to anything else. And if I pull some of these nodes out, let's just pull them up to the side here, we can see that they're just connected to this one node and nothing else. Those clumps like this, or I sometimes call them starbursts, tend to be really uninformative. They're just big globs of nodes that are kind of meaningless in the network. And so the next thing that I would do is try to filter those. So I'll recenter the graph here. So I already have my giant component filter. So I'm going to click this little down arrow. That lets me put in a subfilter. So after we filtered the giant component, we're going to do another filter. And I'm going to try a degree range here. So I'm only going to include nodes with a certain degree. Let's see here. Actually, since this is a directed network, let's get rid of that. And we'll look for in degrees and out degrees. So let's pull in an out degree range. Here's another one of these starbursts. Let's just look at this one more time. So we've got this big clump of nodes here, and if we kind of pull them out and separate them, if you zoom in, you see there's just an in degree coming in. There's no out degree from this node. So I want to get rid of all those that just have an edge coming in. Hopefully that'll get rid of our starbursts. We'll zoom a little just so we can see. So I'm going to click on the out degree range. Now you get sliders down here, and those can be nice, but they can also be really hard to get on a specific value. So like if I wanted to make this 1 and I go to slide this, sometimes the next value I get is really high. A little trick in Gephi is that you can just double click that number and type the one you want, hit enter, and then you get the network that you're interested in. So if we bring that back down to 0, this is our original network. If I put it at 1 and filter, I get a much smaller network with fewer of those starbursts. There's still one up here, but this looks like a little cluster, so that's better. Let's lay that back out. Okay, and now you can more clearly see we have 2 of these sort of starbursts here that didn't get caught.
So let's take a look at what's going on. If I pull these out, zoom in on those, these nodes still have what looks like one edge coming in, but that's probably counting the nodes that we filtered out. So if we try to make our out degree setting 2, that looks a little bit better, though we still have these big clumps here, which is not quite what I want. But an interesting feature that I can see is that they're all connected to this node here. And similarly, we have a clump here and the center one all connected to this node. These two nodes, I suspect, are going to be uninformative, but let's run some additional statistics to see what's going on. So we'll center this again. And now I want to go to statistics up here. Let's actually do average degree. That's going to get us the degree of every node. And then I'm going to color code and also size code by degree. I like to sometimes do the same attribute for both size and color because it makes it extra prominent. So up here where I look on the appearance, this is for color. And for nodes, I'm going to pick an attribute and choose degree. Apply that. And so already that's a little easier to look at. For size, I'm going to pick an attribute and degree. This is set with a minimum of 10 and a maximum of 50, which is sort of the default that I use because it just makes it easy to see all the nodes. So if we apply that, we can look back at our network here, and we can see we have 2 giant nodes in here, which are the 2 that are connected to those little starbursts. They are way above any of the others in terms of their degree, and in fact, we can now go to the data laboratory and sort our nodes by the degree. And if I do that, you can see we have these 2 nodes that have this huge degree up here, and then it drops down by an order of magnitude. So if you're interested in just the role of these nodes, these 2 are going to be super prominent ones that you want to spend a lot of time figuring out because they're connected really intensely in the network and they're important. At the same time, they're getting in the way of us seeing anything else. So mark those down, figure out what they are, do some side investigation, and now I'm going to select them both and delete them. Okay, so with those gone, we can come back to the overview. And now this is our network. A bunch of things have disappeared. I'm going to lay that back out. I'm going to stop that now. Reapply our sizing, reapply our coloring. I might want to rerun this just to make sure. Okay, and what we can see is that we get a much different looking network happening down here. So now we can look at a little more in depth as to what's going on. So let's color our node's attribute by the node type, which is something that was pre-supplied. We loaded that up with the data set. And what we can see is that everything left in here is a hidden service. There's no IPs, there's no clearnet. Everything left in here is a hidden service. That means we've filtered out all the clearnets and filtered out all the IPs. Okay, so that's sort of interesting. This is the bulk of what we're seeing in our network. If we go back to our filter and we get rid of our degree range filter, let's just put that down at 0. Okay, so now a bunch of nodes popped back up. Let's relay this out. So this is with all of our clumpy nodes, but since we've eliminated those 2 big nodes, we're going to see a little bit more. So here we go. We have this new network, a little weird looking. So let's do a few things in here. Let's try again color coding by node type, and now we can see all those nodes that we had filtered out before.
So here's an interesting thing we can try. We
largely clear
size
nodes,
the nodes
and then there's some IPs
degree.
in there. And you can see there's a few little
And now you can
here.
see, for example, this
But
one
that
right
means
here has
that
a very
most of
high
our
in degree.
clearnet nodes
And if we
have
size
a
by
very
out
low
degree,
degree, and
it has
they
a
have
super low out
no
degree.
out degree.
And we've got a much
where
higher
the
out
hidden
degree from
services
these
have
nodes
a much higher
down
out
here.
degree. So that's an interesting
So that's sort of
thing that we
interesting.
can find out
Usually
about
you
these.
have
kind of a
we can now run
match in
some additional
the very high
statistics.
degree
Network
nodes. I have
diameter is
very,
always a good one because it gives you
high
betweenness
in and
centrality,
out degree,
which is an
or they
important
tend not to
measure
be so
of
prominent.
which
So
is very
nodes
interesting
have a
that
lot
this
of influence.
very prominent node here has a vastly different in and out degree.
If we go by color, we can color by betweenness centrality and apply that. Let's change this here. There we go. So we get a spectrum. And let's do the same thing here. So now our betweenness centrality is dictating both the size and the color. And so we can see we have high betweenness centrality here on that node and a handful of others. The one that we were kind of curious about that had big difference between the in and out degree, that turns out not to be important at all in terms of betweenness. If we wanted to investigate one of these nodes further, we could click on this guy. See if we can pull him out of the way. All right, so usually you can do select in data laboratory. I probably have something else selected, which is why that's not working. Fortunately, we can just come to the data laboratory and sort by betweenness centrality and see who this is. So this is another node that we probably would want to pay a lot of attention to because it has this very high betweenness centrality. And in fact, if we scroll through here, we are now sorted by betweenness centrality. If you look at the node type, you can see all the high betweenness centralities are hidden services. And of course, that goes along with the fact that when we had things filtered by their out degree, there were only hidden services left visible. Everything else had a pretty small out degree, and that's where all the other node types were. So we have to get down here to betweenness centralities of 0 in order to actually start seeing other types of nodes, which is pretty interesting. So that tells us that the hidden services are far more important in this network than the IPs or the clearnets. So there's a lot more to look into, but just with an initial analysis of the data that's in this network, that gives us some insights as to who's important and what the different node type roles are. Okay, so you can see here I've got a new window. I've opened up basically the same graph, but there's a little bit of a difference. If we go to the data laboratory, this one has keywords as another column. And you can see here, this node has gun, sex, and drugs as keywords. This one just has drugs. Clearly not all the nodes have keywords, but if we scroll through, we can see them scattered throughout. And so what I can do is use those keywords as another way of understanding the network. So let's go back to the overview, and we're going to click on filters up here, and there's a bunch of options that you can choose from for filters. If we go to attributes, here there's one called equal, so that's if the attribute is equal to something. And you can see our attributes, keywords, and node type are in here. But I actually want to look at all the keywords and just get rid of the nodes that don't have them. So if we go down, you can see there's non-null. So null means nothing, that there's no value. So I want to find all the nodes that are non-null for keywords, which means they have some value for keyword. So I'm going to drag that filter down here and then apply it. And you can see now just in the picture that our network is a lot smaller. And if we look at the statistics up here, we only have 2.5% of the nodes and 3% of the edges. So most of our nodes didn't have any keywords, which is fine. So now we have a much more manageable network to look at. So I'm going to do the forced atlas layout again, though because this is a small network, we don't necessarily need a fast one. So let's see what we can see there. We have these scattered single nodes on the outside, which aren't going to be really useful for a topographical analysis. If we scroll in, here we can see our main network. Let's try another layout just to see if we can see anything better there. Yifan is one that I like a lot. I think it makes interesting looking visualizations. Okay, so we can see here that we have the same kind of thing that we had before, where we've got these kind of starbursts, a node that has a bunch of singletons coming out of it. But because this is such a small network, we can kind of leave those and just see what's going on. The next thing to do is to color code these. And if I come up here, I can color code the nodes by attribute, and keywords is one of those. So we can see all the keywords here. And it's interesting, we can apply just the default colors that they have and, kind of see some differences, but it's not super informative. We have to keep going back to figure out what the colors mean. But since we have 3 main keywords here, null we're not seeing because we filtered that out. We have sex, guns, and drugs, and then combinations of those. What I would do in this case is to take primary colors. So I will make this one red, this one blue,
and drugs yellow. And then for the combinations, I'll actually just combine those colors. So for example, we have guns and drugs here. Well, I've colored guns blue and drugs yellow, and so I'll make the combination of those, just like if you mix those two colors. So I'll make that green. A little bit darker so it's easier to see. Now here we have all three, guns, sex, and drugs. So if you mix all those together, you get kind of a brown if you're doing it with paint. I'm just going to make it a gray to show that it's all of them. Sex and drugs gives us red and yellow, so we'll make this one orange. And then guns and sex, blue and red to give us purple for this one. Okay, and so if we apply that, now we kind of see a spectrum of what's going on. Okay, so there's a few things that we can see with the coloring now. First is that we have this cluster down here of nodes that are gray, so they have all the keywords. And then you can kind of see a patch here of a bunch of green ones, so that's our guns and drugs. There's a bunch of kind of scattered ones that are our primary colors, red, blue, and yellow. So they just have one keyword. And let's now actually see what effect the keywords have on the importance in the network. So I'm going to go to statistics. There's a bunch of statistics that we can use to determine importance in centrality. I really like network diameter because it gives us betweenness centrality, which is a really popular one. Again, that means that a node is kind of a gatekeeper between different parts of the network. And then we can choose the size up here based on the attribute of betweenness centrality and apply that. And so now we can see that we have these yellow nodes and some green ones over here that have really high betweenness centrality, and then one red one over here. If we come back to the coloring, we can see that the yellow ones are drugs, the green ones are guns and drugs, and we only have one important one over here that has anything to do with sex. So that's sort of interesting. We can try different kind of centrality. Eigenvector centrality is similar to what Google uses, which we see up here as PageRank. It basically iterates on who's the most important node. So if we try to resize based on eigenvector centrality, now we see a shift. So it's a similar cluster of nodes that's important. Our one red one over here who was important has kind of disappeared. But we see those yellow nodes that we had before were important. And if we bring our key back up, we can see that this has brought up the importance of some of our gun nodes. There's some blue ones that are important over here. And we kind of have an orange one in the middle, which is sex and drugs right there. That's also become prominent. Okay, so that gives us a little bit of an idea. It's definitely this cluster, this group of nodes down here that are really important for us. We can try doing some other filters. So let's keep the filter that we have for non-null keywords, and then we're going to go to topology and look at degree range, and then start filtering out nodes that are the singletons. So let's try having a degree of 2. Oh, okay. So when that happens, that means it's got rid of our filter. So now we want to reapply it. And let's drag this a bit and see. Okay, so the reason, like what you might be seeing here is that I have to drag that degree up really high to get some of these nodes to disappear. And that's because they're connected to some of the nodes that we've hidden because they're null for the keywords. And so their degree is actually much higher than what we're seeing here. What we can see is that there's 2 important nodes that are showing up here. This one and this one over here that are connected to a lot of these singletons. That's fine. I mean, those are interesting. Let's try to get a better view here. But they're really bringing in a huge number of nodes. So what we're going to do is actually delete. Well, let's actually look at those first. So we're going to select in the data laboratory. And we can see, I think this is actually one that we saw was important in the last. So it's a hidden service, gun, sex, and drugs. It covers everything. And we see a bunch of the statistics that we've collected. So that would be one to note down to look at later. And similarly, if we select this one and come back here, we can see it's another hidden service that does all 3 with some statistics. So those would be nodes to look more deeply into with the content, but they're kind of screwing up what we can see here. So let's delete them from this visualization. Okay, and now we have a much different looking graph. So we're going to rerun our layout. And what you can see that's done is exploded out a bunch of those single nodes to the outside. That looks like it's done. So now we can come back in here and see a little more closely what's going on. The size is a little distracting here. So I'm going to change the size to just degree, which is pretty similar for all of these. Okay, so now what we can see is that we have this very tightly connected cluster here. Each of these nodes, you can see as I pull it, is connected to a bunch of other ones. So this cluster here, because they're gray, we know they have all three keywords. And that's connected to lots of our other nodes that are mostly the primary colors, but some are green and some are orange. We have a big kind of cluster of green ones here, which if you remember, if we look at the coloring, green is guns and drugs. There's a lot of drug nodes in here, just yellow ones, and then a few orange ones, drugs and sex. So there's yellow involved in all of these nodes kind of in the center here. If we zoom out a little bit, the red nodes, which use the sex keyword, are really out on the outer edges of the network. They're not really central. Now these gray ones do have sex as a keyword, but the ones that are singularly focused on that are kind of out on the outside edges. There are some yellow ones out here too. You can see a bunch of yellow ones on the outsides. Those are our drug ones, but again, there's also a cluster in the middle. But the biggest group that kind of makes up the central part of our network has guns and drugs as their keywords. So that kind of gives us an idea of keyword-wise what's most important. If we come back over to the data laboratory, we can also take one more look. The data laboratory is also filtered, so you can see we only have nodes that actually are showing their keywords here. And if we scroll through, if you look at the node type, these are all basically hidden services nodes. And in fact, we can look at that visually. If we come back here and we pick the color of nodes not as keywords, but as the node type and apply it, our entire graph is purple, which means they're all hidden services. So that tells us that the nodes that have the keywords are hidden services. Now, is that because it's just an artifact of how we collected data? Only the hidden services provide the keywords? Maybe. But it also could be an attribute that the ones that have these keywords for these sort of illicit activities that are happening online all happen to be hidden services, that clearnets and IPs could have them and they just don't. That's something that the visualization can't answer. It can just tell us that there's this connection, and that's something to look a little bit deeper in with the data. So there you go. There's a quick kind of Gephi tutorial of how to look at these networks and the data and do some exploratory analysis. Hope it was helpful.